Did you know that Retrieval-Augmented Generation or RAG is behind some of the most powerful AI tools today? It helps models like GPT-5, Gemini 2.5 Pro, Grok 4, and many other models retrieve relevant information from multiple documents, enabling factually accurate and context-aware responses. Hello everyone, welcome back. In this video, we will be building a multi-document RAG pipeline integrating document ingestion, embedding, and vector storage, and querying with an LLM. Alright, so the first step is to install LlamaIndex, that is a popular library that acts as a middleware for many generative AI workflows. This library helps with document ingestion, embedding, and efficiently creating searchable vector stores, which forms the main backbone of our retrieval step. Now, this library itself is so powerful that you do not really have to manually create these vector stores or have to go through the pain of creating these embeddings. In fact, this takes care of it all for you. Okay, so moving on, we import all the necessary things from LangChain. So we will be using LangChain as well. And our API keys, of course, you will need an API key for this. And let the main thing begin. All right. So documents equal to simple direct reader. Now over here we are just loading our document corpus. We read the AWS case studies and blog posts from the specified folder over here. It'll just scan through the directory, read all the files, and then prepares them into a document object for indexing. This data will act as our knowledge base for our RAG system. If you want to test it on a different data, then you just need to change the documents that you will be uploading onto this folder. And next comes the LLM predictor. So over here, to create responses on the retrieved documents, we instantiate an LLM predictor by wrapping LangChain's chat OpenAI model. We specify the GPT-4o variant, that's the model that I want to use over here, and we are setting temperature equal to 0 for more deterministic outputs, meaning the model will give the same answer each time for identical questions, because as you increase the temperature, it increases the creativity or the randomness. But that's not what we want. We want it to be more factually aligned, more deterministic. So 0 is the best option for us. And then we create a service context, which will package this predictor along with its default settings. So this service context is essential as it will be passed into the index building step to wire up how queries are actually generated and responded to. Next is the GPT's vector store index. So with documents loaded and our service context ready, we now build the vector store index. This process transforms each document into embeddings that are numerical vectors representing the semantic content. And we'll be leveraging, of course, the configured GPT-4o model to use these and answer our queries. So this GPT vector store index organizes these embeddings in a way that allows for efficient similarity searches. So when a query is issued, when you ask a query, this index will quickly find the most relevant pieces of knowledge to pass on to the LLM. And now the LLM will take this data and generate answers based on it, hence making it contextually aware. So the real game is all in the retrieval of the proper data from the documents that are in the vector store. And then this is just storing the index to disk because we would want to avoid repeating the embedding and indexing process every time you run the pipeline, right? So we just save or persist this index onto a disk in any folder over here. In this case, it's the AWS case documents index, which we are keeping it in. So this way the index can just be reloaded in any future subsequent runs. So it just saves a lot of time. Alright, so that was the main task. There really isn't much to this because LlamaIndex itself handles most of the heavyweight tasks alongside LangChain. So let's just go ahead and ask questions now. So over here we are asking, write a detailed summary of AWS, personalize, and in your response provide an executive summary, after which you can present succinct bullet points. Remember to add formatting elements so the output is easy to read and well formatted. Use line breaks to improve formatting. And this is the answer it generates. So this entire answer that it has generated is solely based on the documents that it has retrieved from the vector store and is now using that to answer our questions. Similarly, another question over here, write a detailed summary of the use of machine learning by AWS customers in the life science industry. In your response, provide an executive summary, after which you present succinct bullet points, so on and so forth, the exact same lines that were there on top, just to increase our readability and to be able to understand what it's saying more clearly. And here's the answer. Again, this is also generated based on all the data which we have fed it. So you can really upload any document which you want, store it in the vector store as embeddings, and then it'll be able to retrieve those based on your queries which you ask and give you an answer. That's the whole idea of RAG. And using LlamaIndex and LangChain for this really makes the entire task from daunting to easy. These popular libraries are popular because of that. And that's all there is to it. Just more questions. So that's a wrap for this pipeline walkthrough. You have seen how to ingest documents, build an index over here, persist it, and write a query with a GPT powered engine to get answers from it based on the documents. So if you like this video, don't forget to like, share, and subscribe for more tutorials and updates. Thank you. That's all.